This session is on strings. String is an object that represents sequence of character values. So we can represent strings in two ways. String s is equal to abc, string s2 is equal to new string of abc. So the first one is created using string literal, and we should not confuse this with a primitive type. So string is not a primitive type like integer. Although we created in a similar pattern, like integer a is equal to 10, like that we are doing string s is equal to abc. It's a very common way of defining strings or assigning the string values. But string is not a primitive and it is an object. So it should not be confused with primitives, even though the definition or the way you assign the values is going to be similar. So there's another way which is like a regular object, like person p is equal to new person of. We are doing string s2 is equal to new string of abc. So it's another way of creating a string object. So what's the difference between these two? Let's understand that. String s is equal to abc, string s1 is equal to abc, and we do string system.out.println s is equal to s1. If you are doing it with an integer, what will happen? It is going to be true, like integer a is equal to 10, integer b is equal to 10. If you compare a equal to b, it's going to be true. In the string, let's see how we said it is string is not like a primitive. It's not a primitive like integer. So it's an object. But when we do this with an object, of course, they are going to have two different memory locations and they will never be equal. Let's see what happens with strings here. Even though string is an object, what's happening with strings here? So as I said, string is an object. It's going to be created in the heap memory, right? So how it is going to be getting created is when you create a string using literal form, like s is equal to abc. In this method, if you create a string, it is going to get created in a place called string constant pool. We can also say string literal pool, or we can say a string pool. So it is going to get created in the string constant pool. So how it is going to create it, like abc will be created there in a particular address. So string constant pool is a specific area that is residing in the heap memory to store all the string constants. So here abc is a string constant, so it is going to store abc inside this string constant pool. So what is going to be s? S is not going to hold abc. S is going to hold the reference of abc. So abc is stored in the memory and that memory location will be held by s, just like any other objects. But what will happen when I do s1 equal to abc? It is not going to create one more abc in the string constant pool. It is just going to point to the same memory location. So what is going to happen when you do s1 equal to abc? It goes and sees whether there is any abc present in the string constant pool. Yes, there is already abc, then it is going to return the same memory location to the s1. So now s and s1 receive the same memory location called 4000. Now if you do comparison between s and s1, it is going to be obviously same because they both point to the same value or the same, they hold the same reference basically of abc. So the output is going to be obviously true. The next case is going to be string s2 is equal to abc, string s3 is equal to new string of abc. Now let's compare what will happen s2 equal to s3. So in this case, let's see the memory allocations. When you do s2 equal to abc, of course it's going to be the same way. abc is already there, so it is going to return the 4000 location to s2. When you say s2 equal to abc, it is going to hold the reference of abc, which is going to get 4000. And when you do s3 equal to new string of abc, here we are not doing s3 equal to abc, we are doing new string. Whenever we put a new operator, what is going to happen? It is going to create a new memory location in the heap. So here it is going to create a new memory location in heap. So it is, let's say we are saying 5000 is the memory location, and s3 is going to point to the 5000 memory location, not to the 4000 memory location. So now if you compare s2 and s3, you are comparing the references. The s2 reference is 4000, which is pointing to the string literal, whereas s3 location is 5000, which is pointing to the heap memory. So they are obviously going to be different and you're going to get a false value. Let's say we are doing s4 equal to new string of def. What is going to happen here? Same. It's when I say new string, it is going to create it in the heap memory. So it's going to create it in the heap memory def, but it is also going to do one more thing. Not only it creates the def in the heap memory location, it's also going to create def into the string constant pool. Any constants that you define in the program, a, b, c, d, f, or any constants you create in the program will be created in the string constant pool. Whether you refer to that or not, that's a different story, but it is going to get created in the string constant pool. So you define def is not there. If it is not there, we are going to create a def there, which is going to be in a different memory location. But the point here is S4 is pointing to which one? It's still going to point to the heap memory location because it is created with a new string value here. It is not going to point to 4001, it is going to point to still 5200. Okay. S4 will refer to heap memory and not the pool memory because S4 is created with new string here. The pool memory allocation is just an additional step done since the def is not present there. If it is already present there, like in case of S3 equal to new string of ABC is already present there. So it just creates the memory in heap and it does not create the memory in the constant pool since it is already existing there. Okay. So the advantage of doing like this is going to be efficient memory management. Why they introduced string constant pool is because they wanted to manage the memory efficiently. That is the reason for doing that. So how it is efficiently managed? You see that each constants that you create will be there in the constant pool. So I don't want to create it again. Like if I create ABC, S is equal to ABC, S1 is equal to ABC, S2 is equal to ABC, S3 is equal to, if I create like this, all of S1 and S2 all are pointing to ABC. I didn't create 3 memory locations. Like in heap, I would have created 3 times, this ABC. But since I use string constant pool, I didn't create it 3 times. I just created only 1 time there. So, and I just gave the references to them so that everyone is pointing to the same memory location. So that is the advantage of having memory allocated just once actually instead of having it allocated for 3 times. Strings are immutable. String class is a final class, so which means you cannot extend the string class, and we call strings as immutable. So let's understand how strings are immutable. So in this example, string s is equal to abc, s1 is equal to abc, s is equal to def. So what we are doing here is we are changing s is equal to def. What do you mean by immutable? Means it is final. When something is final, that means we cannot change it. But here s is equal to abc and I'm able to change s is equal to def, right? So how come it is immutable? How are we able to change the value of s? As strings are immutable, how can we change this? It should not be possible, but actually it is possible. You can change the values of s. So then how do we say that it is immutable? Let's understand that. So in the memory, when you say s is equal to abc, of course it's going to create that in constant pool and it's going to have 4000 and let's say 4000 as a sample, hypothetically. So s is going to point to abc, means s is going to hold the value of 4000. And the moment I say the next thing is s1 is equal to abc, which is also going to hold 4000, which we know. The moment I say s is equal to def, what's going to happen is df is not there in constant pool. So it is going to create a memory location called df, which is 4001. Now what is going to happen here is s is now pointing to abc, means s is holding 4000. Now I say s2 point to def, that means s go and point to def means whatever memory location is there for def, you change to that memory location. Now what will happen to s is going to give away the value of 4000 and it is going to point to change it to 4001. So if you understand it, here s is changing from 4000 to 4001, but abc is not changing. ABC is still sitting out there. We are not updating ABC to def. Once the strings are created, it is created. You cannot alter it. You cannot update it. What can be done here is instead of making the S2 point to ABC, we are making the S2 point to def. That means we are changing the references here and we are not updating the string here. We are not updating ABC to def and we are not losing ABC here. We are not changing the contents of ABC. We are creating a new memory location and putting def there. We are not changing the ABC to def. That's the whole point here. which means strings are immutable. Once you have created the string, you cannot alter the string. What can be done is you can point the reference from that string to another string. So S was originally pointing to ABC, now it is going to point to DEF. So let's take one more thing. When I say s1.concat of xyz, I'm running a command like s1.concat of xyz. So what will happen here? S1, what is it pointing to? It is pointing to basically what? It's pointing to ABC. S1 is 4000, so it's pointing to ABC. Now I wanted to concatenate ABC with XYZ. So XYZ is a literal which is not present in the constant pools. The first thing what happens is XYZ will be created in the memory location. Now we will take S1 value which is ABC and XYZ which is 4002. We will be combining these two and then creating ABC XYZ in a new memory location. That's it. So nothing will happen after this because still S is going to point to 4001. S1 is pointing to 4000. Even though XYZ and ABC XYZ are created, no one is pointing to that memory location. S1 still points to ABC only. We didn't change it. So we have to be very careful when we are working with strings. All the time when you do s1.concat of xyz, it's not like a regular object. So what will happen here is, here you have to put s1 equal to s1.concat of xyz, which means now s1 reference will be changing from 4000 to 4003. If we don't put s1 equal to, then that means we just create the string and it is going to sit in the constant pool, but no, there is no reference to that string. So we will not be able to access that string. It just creates and sitting it over there. So the moment you say s1 equal to s1.concat of xyz, now it is going to change from 4001 to, 4000 to 4003. So if you are having such operations like a lot of string manipulations, like if you are using a substring, concat, index of lot of string manipulations, if you want to work with, it's better to use, string buffer or string builder instead of strings. Because as you see, when you use strings, it is going to create for each memory location. If you are trying to do s1.concat of xyz, it is going to create a new memory location. It's not the intent. If our intent is just to update ABC to ABC XYZ, here it is not going to happen like that. It's going to create a new memory location for that. So for any intermediate values in your manipulations, everything is going to create one more memory locations, which is going to eat up your space there. So instead of doing that, you have to use string buffer and string builder, which is an efficient way of doing it. We'll learn about string buffer and string builder in the next session. So we'll discuss shortly about what are the methods supported by string. We'll see some demo sessions on few methods, which we will be using in a day-to-day programming. So we'll quickly summarize what are the important methods in string. So we have concatenation method, which we saw now, which is used to concat two strings, and we have trim method, which is used to trim the white spaces in a string. We have lowercase uppercase method to convert your string to a lowercase string or an uppercase string. We have substring method to extract a part of the string. We have replace method, which is used to replace a given value to another value. Suppose if your string is having let's say your string is a test, and if you want to replace test to a different value like say Java, you can use the replace method to do that. We have one more method called replace all, which works with regular expressions. We will see in a demo for that, so that to understand it better what is a regular expression. We have split. Split method is used to basically split the string into number of into a string array. Here what we mean here is let's say you have a string with a long string with a comma separated values, and if you put that string dot split of comma, you're going to get a string array which is going to be having the strings before and after the commas actually. So it's going to basically, if you have five strings which is all comma separated, you are going to get a string array of 5. You have equals and equals ignore case. So unlike equal to always do a reference comparison, basically the memory comparison. Here equals and equals ignore case is going to compare the contents actually, not the memory locations, not the references. It's going to compare the contents here. We have contains to check whether a string contains another string, and we have starts with, ends with, which is going to check whether a string is starting with a given letter or a given string and ending with a given string. And we have length method to calculate what is the length of the string. We have compare to method, which is to calculate, which is to compare two different strings. We have index of methods to find in a given string where the another string is there. What is the position of the what is the position of the passed string in a given string? Here the last index does the same job. What is the position of the given string in, I mean, what is the position of the passed string in a given string? But it does in a reverse way. Instead of going from left to right, it comes from right to left. So it starts from the last index actually. We'll see some examples over this as well. Let's move on to Eclipse. So let me create a class. So I'm going to change this to strings. Make it as demo, string demo. So we'll see some important methods here. So it's very self-explanatory. You can the moment you put dot, you will get all the methods in the string, and you can play around with those methods. So let's see something which is commonly used. So we have a string s equals, say, Java session. Now what I do is I would say s dot concat of so just add something to this s dot concat of Java session for beginners. Now if I do system.out.println and then say s, it will just print Java session, because as I said, strings are immutable. So what will happen here is there will be a new string created with Java session for beginners will be created, and Java session for beginners will be created in literal pool. But we are not pointing s to that actually. S is still going to hold Java session unless you say s equal to s dot concat. You will not see the difference here. So the moment you say s equal to s dot concat, now s was pointing originally to Java session, now it is pointing to Java session for beginners. So there is no reference for Java session now. Okay. So we can use a lot of string functions or string methods. So we can say s dot to lowercase method, so which is going to convert everything into lowercase, as you see here. You can also say s dot to uppercase, which is going to convert into uppercase. You can have string.length, which is going to print the length of the string. Okay, it's 26. So the other thing we talked about the split method. So we can say string array, say words equal string array words equal s dot split of space. So if you see our string, we have Java session for beginners. So there is a space here, space here, space here. I want to get that into 4 strings. So this will help me to do that. So now I have string array words equal to s dot split of space. Now if you want to print the words, you can simply say for each string s1 present in the words. This is an enhanced for loop. We can simply say this out. Sorry. So basically it's going to get all the strings and print it. You can also do in a different way. If you want to have, let's say, if you want the first out of it, instead of printing all four, if you want to say words of 0, so we captured in words, and the words of 0 will have Java, words of 1 will have session, words of 2 will have for, and words of 3 will have beginners here. So I'm printing just words of 0. It's going to give you Java here. Okay. So the next thing is you can use substring. So how do we use substring? Let's say string. So let's say we wanted to take like let's take a simple string instead of going too far. I'll keep okay, I will use concat function here. String s2 equals, I want to concat two things, words of 0 dot concat of words of 1. You can also use plus here. This is one way. You can also use words of 0 plus words of 1. Words of 0 is Java, words of 1 is session. So I'm just going to concat both things. And I'm going to print s2 here. So it's going to give me Java session here. Okay. So now let's do one thing for the substring. I want to get, I have s2 which is Java session. I want to get the substring here. I wanted to start from, I want to give the begin index to 4. So let's see what happens here. This out s2 dot substring of 0 comma not 0 comma 4, just give 4. So here what's going to happen is it's going to just give session. How it is giving is, I'm saying begin index is 4, substring of 4 means it's going to start with the 4th character. So J is the 0th character, A is first, V is second, A is third, 4th character is S. So it's going to start with the 4th character and print the rest of the one because we didn't specify any end here. So it's going to give me all the rest of the string actually. But you can give like, I wanted like you can give a begin index and end index. Like you can say I want to start from 4 and I wanted to print the print till the end of the string. So I can say s dot length. Basically they mean the both the same actually. It's going to print here as well session. I'm sorry. So you have to give s dot length -1 because all the time I'm sorry, so what's happening here? I said is 2 dot, so sorry about that. Don't need -1. Okay, you got session here. So basically when you say 4, it's going to take till the end of the string. If you don't specify anything, if you can, but you can also specify, like say I want to retrieve the last starting from the 4th character, I wanted to get or starting from the 0th character, I wanted to get the last I want to ignore the last three characters. Then I can say -3 here. That means it's not going to print the last 3 characters in the string. So it's just going to give as ION is ignored here because I don't want to print the last 3 characters. So here it is just nothing but a simple, you can s2 dot length is nothing but 1 2 3 4 5 6 7 8 9 10 11. So s2 dot length is going to be 11. So you can even specify 11 minus 3, which is 9 actually. You can you can specify 8 here, which means it's going to start from 0 0 1 2 3 4 5 6 7 8. That means 8 is not counted. It's going to say like 0 to 8 will be printed actually. That's the meaning of this substring. Instead of specifying 0 comma 8, I'm saying 0 comma s2 dot length minus 3, because I just want to ignore the last 3 characters from the string. So that covers what is substring. So there are 2 variations of substring as you see here. The next thing is we have like index of. Let's see that in a, index of. So index of is here in substring we are giving the index where it starts and where it ends, type of thing. But if you wanted to find this index, you can use index of function. So let's take one new string. 3 equals Java is Java is reversed. Okay. So this is my string, and now in this string I wanted to find out where is Java. How can I say that is simply say system.out.println s3 dot index of. You can give a character or you can give a string here. So I'm giving a string here, s3 dot index of Java. What it means here is it's going to print where is Java. So it's going to give 0. That means Java is in the 0th character itself. Okay, if I change it to is, where is this? Is in the 5th character. You see 0, 1, 2, 3, 4, then 5th character is there. So it's always going to give you the first character. First occurrence basically, the position where this string is first occurring. Let's say I want to locate Java, but I wanted to find out not the first one, I want to find the second one actually. How do I do that is, instead of searching from the beginning of the string, you can specify from which index it has to start the search from. Let's say I'm saying you start the search from comma 1, which means it's going to start the index, it's going to start the searching for Java from the first character. It's not going to consider this. When it is starting from the first character, Java is coming in the next Java is coming only in this position, right? So what's going to happen here is, if you do this, it's going to give you 20. That means the next position is on 20th. So you can specify from which position you need to start your search to find the next search string. So there is one more variation of this. You can also give instead of index of, you can give a last index of. So this is, instead of searching from beginning to end, the left to right, it is going to start from right to left actually. So when I give Java here, without giving anything, instead of index of, if I give last index of Java, it is going to locate this location first actually. So it's going to give me 20 because it's going to start from here and find Java coming from the last actually, instead of coming from the beginning. I think we covered all the important methods that we use in string. The 2 other important methods that we mostly use is the replace and replace all. Let's open up a new class and do that. Okay. Okay. So let's take one simple example for replace. So string s equals Java. So I can say system.out.println s dot replace. Say I can give a character or I can give a string here. Okay, character sequence. So instead of A, I'm saying instead of A, change it to B. So all the A will be changed to B here. So if you see here, Java is replaced to JBBB. Now you can also do a string replacement. So say replace Java in the string, wherever you find Java, replace that with say C sharp. Okay, so here let's say Java is a programming language. Java is robust. So now when I say replace Java with C sharp, what is going to happen is it's going to replace all the Java to C sharp. C sharp is a programming language, C sharp is robust actually. So replace function is used to do either replace a character or it will be used to replace a whole string itself. Okay, so we'll see the replace all. We can use, in this case you can also use replace all instead of replace. It doesn't make any difference, but replace all is more powerful. So in this case there's no difference, it's going to be same, but replace all is a more powerful thing. Let's see with one example here. We will use, okay, string str equals okay, test 1 2 3 4 and give like sample. Okay, so this is my string and I want to replace all here. So I'm going to copy this. So instead of is, I'm going to say it as str dot replace all. I want to replace all the digits basically, you know, all the digits. I don't know where the digits will be coming, and you know, I don't want to specify 1 2 3 4. It can be any digits, like it can be 9 5 7 8 6 7 8, like it can be any digits of any length here. Okay, so if I want to do that, what I will do is like I can specify a regular expression here. So this is one regular expression where I say, you know, 0 to 9. Can specify A to Z like that. You know, the regular expression itself is a separate topic by itself, but I'm just giving a hint like how can you use regular expression for, you know, using with replace all. So how basically replace all is different from replace. So here I say like, you know, anything in this string, anything that matches with 0 to 9, okay, make it to space. I mean, don't do anything, just replace it with the empty value. So let's run this and see what is the output. As you see, the 1 2 3 4 is completely replaced with the empty value. I didn't specify 1 2 3 4. Any digits will be replaced here. So if I wanted to have like, you know, anything at the end, sorry, if I have like anything at the end and the beginning, like okay, so none of the digits is going to appear in my string. It's going to completely wipe out all the digits here, because I said any digits, replace it with empty. But you cannot do this with the replace function. Replace is going to work with a specific string here. It's not going to work with the if I do the replace here in place of replace all, it's not going to replace anything, because it doesn't find a string called 0 to 9. It does not find anything, a string with which is starting with the square brackets and having 0 to 9 in this whole string. It does not do a regular expression replace. So when you do a replace, nothing will happen. It's going to print the same string again. But in replace all, it is going to strip out all the digits in it. Then we have like yeah, there is one more method called matches. Again, it's based on the regular expression. So let me put simple thing. So this is a regular expression for validating whether a phone number is correct or not. So simple regular expression. So we will have like 0 to 9. So if it is a phone number, it has to have 0 to 9. And it should be of 10 characters, right? I mean 10 digits basically. So I will mention that this is the way to specify how much length it can have actually. So this is my regular expression, and I can say string phone number. I can give some phone number. So give like 1 2 3 4 5 6 7 8 9 0. It is having now 10 digits. Okay. Now if I do this out and say phone dot matches regular expression. Is the phone is matching with the regular expression. That means whether the user supplied phone number is the correct or wrong, actually, whether he's in a valid format or not. So you can specify a regular expression for email or anything like that. You put in a form if you want to specify a regular expression to validate it. It's an efficient way to do this by using the matches function. So if you see in the forms, we will be entering the phone number, we'll be entering the email address and all these things. So if you want to validate and throw an error if the email is not in a valid format, or in a phone number is in a no, it's not in a valid format, those things can be handled using the regular expressions. So now if I do run this, I'm sorry. Oops. Should be true. Yeah, it should be true. I have an extra space there. Okay, so now if I change this to, let's say, A, still it is having 10 digits in it, I mean 10 characters in it, but it still is false because we expect only 0 to 9 and that has to be in 10. So we don't expect anything other than 0 to 9. You can specify, let's say, even if you have 1, 2, 3, just remove 1. Now say like this, it's going to be false. It's not going to be true because we have just 9 digits. But you can also adjust this, it can be 9, you can say, and it can be having a minimum of 5 and maximum of 10, like this you can specify. So now if you give, it's going to be giving us true because it's minimum is 5 and maximum is 10 we are giving. So, but if you add more, it's going to error out here. So it's going to say false here. So the same regular expression, if you specify, it can match with different inputs and provide you whether that expression is or the input is valid or not, actually. So there are a lot of string functions, but most of the utility functions we have covered in this session. But still there are a lot of more string functions you can learn. If you just put dot, you are going to get everything. Character, it is going to get the character. I mean, what is the character in a given position? And yeah, two more things we will see actually. One is the equals and the equals and compare. These two are something which we will be using mostly. So equals, basically string, let's say string s1 equals let me put it in a new program so that it's followable. So we have string s1 equals abc. Sorry. And s2 equals abc. Let's make it as new string of abc so that the references are different. Okay. So if I do s1 equal to s2, you basically know it is going to come as false because they two are different memory location. But if you do like string s equals abc and compare basically s and s1, they are going to be true basically because they point to the same memory location in the string literal pool. S equal to s1 will be true. So first one is true and second one is false because these two are two different memory locations. They are same memory location. As these two are in the literal pool and this is in a heap memory, they are different. Okay, now if I do like s1 equal to s2 instead of this, if I do s1 dot equals s2, sorry, s1 dot equals s2, this is false but this will be true because dot equals is going to compare the contents actually, not the references here. Just like here, it is not going to compare the references, it is going to compare the contents actually. And if at all, like, this is when it is comparing the contents, let's say this is having capital A and this is having small a. Now when you do s1 dot equals, it's still going to give you false because ABC is not equal to this ABC. They are different in the, you see it's false here. So now for that to, if you don't worry about the case here, you can always use one more method which is called equals ignore case. So this will basically give you true here. There is one more method called compare, so which is used to compare two strings. So you can use that method to compare two strings. So here is one dot equals, you can say compare to here. So this will basically give you an integer. It basically takes this ABC and compares with this ABC. Now when it is comparing, it is going to take the lexical value and compare it. So the ASCII value of A is 98, this A is 65. So it is going to subtract this 95 minus 65. Sorry, 97 minus 65. When it is subtracting, it is going to get a positive value. So that's nothing but 32. So when you subtract 90, I think 97 minus 65, 97 minus 65, you should get, yeah, 97 minus 65 is 32. So you're getting that value here actually. But if you are doing it in the reverse, like if you're doing s2 dot compare of s1, then you're going to get a negative value, negative 32 here. So which means that the second string is, when you get a negative value, then that means this is lesser than this actually. When you get a positive value, that means yes, this is the first value is greater than the second value. If you get a negative value, the first value is less than the second value. If you get 0, then they two are equal actually. That's the meaning of this. So what it happens is, like if you say like here it is ABC and here it is ABC ABD, assume, okay, instead of C I'm having as D here. Now what will happen is, it will first start with A, compare it, it will get 0. Then if it is 0, it goes to the next letter and compares it. That is also 0. So then it goes and compares with the next letter, and now it is a difference is there. So it's going to produce the value here. It doesn't matter, like if at all you are having a big string here, still the first string is greater than the second string, because C is going to have something like 99, but this D is a capital D, so it's going to be 66, 69 I think. So when you subtract these two, always this small c is going to be having the higher ASCII value. So when this comparison is happening, that's all. It is not going to, if this itself is resulting in the positive value, not non-zero value, it is going to break there and going to result in a positive comparison. So when I say now s2 s1 dot compare of s2, in this scenario it's going to give me a positive value, even though s2 is having a bigger string here. But when you compare C minus D, it's going to give you 31 and it's going to result in a positive value. That time itself it will exit from the loops. So if you wanted to compare basically irrespective of positive or negative, let's say you have like this, now it is going to be giving a positive value because the first string is greater than the second string. But if you want to compare the irrespective of case, there is another method which is compare to ignore case. So now it's going to give you 0 here because they are not going to compare with the case, so it results in 0. I think that's it about strings. There are a lot of methods out there. You can convert a string to a character array using two character array method. You have contains method, starts with method, ends with method. You can practice those things. But most of the important methods are covered here. Yeah, I think we covered most of the important methods in strings. Thank you.